Okay, the next thing we're going to talk about is geometric series. Super interesting. Okay, so now let's start with a identity that I know I've presented to you before, but let's just revisit it. And that's this identity. We're going to take 1 plus x squared all the way up to x to the n equals 1 minus x to the n minus 1 over 1 minus x. Okay, and you can find that this is true. Just you multiply this by this. Okay, so what I mean by that, when you do this multiplication by 1, it's going to give you all of this again. When you multiply by negative x, and you get a negative x here, negative x squared, x to the n minus x to the n minus 1. All these terms cancel. Plus 1. Sorry, it should be a plus 1 there. That. Okay. All right, so that's our geometric series. Now, our question is, what happens if we keep this going forever? So we write it like this. Okay, remember when k equals 0, x to the 0 is always 1. Okay, so this equals, well, it's actually going to converge if x is small. If x is smaller than 1, it's going to converge to 1 over 1 minus x, and that's going to happen if the absolute value of x is less than 1. It diverges if x is bigger than 1 or equal to. Okay. Now let's do a couple of things I want to do just real quick before we go too crazy into this. Too late, right? Let's not start from 0. Let's imagine that we had um, x to the k plus x to the k plus 1. So it's going to be the sum. Now I'm going to do n equals k to infinity, x to the n, yes, x to the k, x to the n. Okay, so now what I could do is I could factor out an x to the k. And what's going to happen here? I'm going to get 1 plus x, x squared, and so on and so forth. That equals, now assuming that we have a convergent geometric series, x to the k over 1 minus x. So we can sort of do a little bit of we can extend this. We can say that the sum n goes from k to infinity of x to the k is x to the k over 1 minus x. I'm usually not going to use this. I'm usually going to use this one and just factor it out. But it's just good to know because you will sometimes see this used as the formula. Okay? All right, so let's do an example, a nice one. This is the one that has a very nice picture example. You know what? I do this one all the time. Let's do a different one. Let's do 1 plus 1/3 plus 1/9 plus 1 over 27. So this is 1 over 3 to the k. Okay, so our x is 1/3. Okay, so this is going to be 1 over 1 minus 1/3, 1 over 2/3, that's 3/2. Okay, let's draw, there's a nice picture that goes with this. Let me draw a couple of boxes. Try that again. I want to make these bigger. Okay, we're going to start shading it in. We're shading in, I mean, it's already shaded, but we're shaded in with orange. We get one of them. That's representing this one. Now, we're going to take a third of this next box. So a third, we're going to split it up into thirds. Let's go like so. Okay, that's a third. Now we're going to take a third of a third is 1/9. So a third of a third is 1/9. So we're going to take a third of this box. Okay, so each one of these boxes represents a 9th. Now we're going to take a third of a 9th, which is 1/27. So we're going to take one of these boxes and split it up into thirds again and fill it up. Okay, and you see where this is going. We're going to take this box and fill it up into thirds. Okay, we're going to take one of these boxes and fill it up into thirds. Do you see where this is going? We're actually going to get a half of this box. Okay, this piece is going, and you see that I may have done this one. I may have drawn it the wrong way, but we're getting half of this. Okay, so that's the 1, and this is the 1/2 here. Okay, wish I could have drawn it. Let me try that again. Try that again from here. From the 1/3, we're going to take the 1/3 box and split it into 3. Fill one up. Okay. So now these are 1/9 boxes. Split them up into 3. 1/27. These are 1/27 boxes. Split them up into 3. Okay. And so we end up getting really half of this box. Okay. All right. Let's we'll do a couple more, but we'll do it in a new video.